linear relationship is a relationship where the dependent variable changes at a constant rate with respect to the independent variable. In these relationships, the points can be plotted on a straight line. In the word linear, you should see the word line. So think linear, think straight line. The independent variable is the variable that you can control or change, and it is found on the x-axis. The dependent variable is the variable that depends on the independent variable and is found on the y-axis. It changes in response to changes in the independent variable. A real life example. So consider the amount of money you earn at a job where you're paid by the hour. In this case, our independent variable is hours worked. The dependent variable depends on the independent variable. It is the response variable, the results variable. So money earned changes in response to the number of hours worked. So money earned is our dependent variable. Linear relationships can be represented by the general equation y equals mx plus c. X is our independent variable, the input variable in our equation. Y is our dependent variable, and this is the output in our equation. M is our slope, which shows the rate of change. And C is our y-intercept. It shows the starting value. Number 1, create an XY table of values for the relationship between money earned and hours worked. In this case, I'm simply going to use an H for the number of hours worked, and I'm going to use M for the money earned. At our first point, we have the number of hours being 2 and the amount of money earned being 15. At our second point, we have hours worked being 4 and the money earned being 30. At our third point, we have hours worked of 6, money earned being 45. At our fourth point, we have question 2, write an equation representing the relationship between money earned and hours worked. If we look at those values, as the hours increase, the money earned also increases. So let's have a look at the rate of change. From our first point to our second point, what happened to our money earned value? We increased by 15, so that's a positive 15. I'll put that on top. What happened to our change in hours? From 2 to 4 hours, we plus 2. So that's a positive 2. And we can see that we have a rate of change of 7.5, 7.5. We can say that we have the following formula. Money earned is equal to 7.5 multiplied by the number of hours. And you can actually check that for yourself. What is 8 multiplied by 7.5? And you will see that you get 60. Question 3, what do you notice about the rate of change? Well, the rate of change for every single H and M combination. So it could be this yellow combination here from 6 to 45, or it could even be from 8 to 60. Every time we are multiplying by 7.5. The rate of change is constant. More linear relationships. Let's have a look at distance and time. Consider a car traveling at a constant speed of 60 miles per hour. So the independent variable would be time. The dependent variable is distance because distance depends on time. Using the distance, speed, time triangle below, write an equation for this linear relationship. Distance is equal to speed multiplied by time. So we can say distance equals our speed of 60 multiplied by t for time. After completing an XY table of values, draw the graph showing this relationship. We have time as our independent variable. We have distance as our dependent variable. So let's use some values. 1 hour, 2 hours, 3 hours, 4 hours. What would our distance be? 60 times 1, 60. 60 times 2, 120. 60 times 3, 180. 60 times 4, 240. So let's plot those points. Our first point, our second point, third point, and our fourth point. Last, we just join those dots with a straight line. And there is our linear relationship. Our second example of a linear relationship, we have for a cell phone plan. We have a $20 monthly fee plus $0.50 per minute of talk time. In this case, the independent variable is, what can we change? We can change the talk time. The dependent variable is the total cost. Write an equation for this linear relationship. In our previous example, we know that the rate of change is the coefficient of our independent variable. So in this case, we have a rate of change of, so already we know that our dependent variable is total cost. Now I'm just going to do a big C for total cost. The coefficient of our independent variable t time is 0.5. Our independent variable is time. I will use a t for time. And what would be the cost at a time of 0? At a time of 0, our total cost would be $20, that fixed monthly fee. After completing an XY table of values, draw the graph showing this relationship. I'm going to use T for time and C for total cost. At a time of 2 minutes, I have 0.5 times 2, a half of 2 is 1, plus the 20, 21. We can now plot our points on the coordinate plane. 221, 422, 623, 824. And finally, we connect the points with a straight line. And what we can do, we can extend that line to the y-axis to our y-intercept of 20. And there is our linear relationship. Progress check. Have a go yourself, then check your answers with mine. First question, a bakery charges $2 per cupcake plus a $10 delivery fee. A, write an equation for this relationship. We are finding the total cost. C, what is our rate of change? The cost changes at $2 per cupcake. So the coefficient of n being the number of cupcakes, is 2. And we have our $10 delivery fee, so that will be added to get our total cost. Question B, create a table of values and plot the relationship. Let's say we have 1 cupcake. So you substitute n with 1. 2 times 1, 2, plus the 10 is 12. What if we have 2 cupcakes? So we replace n with 2. 2 times 2 is 4, plus 10, 14. We've created a table of values. Now we need to graph the relationship. First, we need to decide our dependent variable goes on the y-axis. That is our total cost. And I remember to label my x-axis. I'm going to say number of cupcakes. Now it's just a case of plotting the points. I have my 5 plotted points and I connect the points with a straight line. There is my linear relationship. Question C, calculate the total cost for ordering 12 cupcakes. I have the equation and all I need to do is substitute into my equation. My total cost is equal to 2 times the number of cupcakes, 12 cupcakes, plus the 10. 2 times 12 is 24. I add the 10 to 24. My total cost is $34. Last question. A phone company offers a plan with a fixed monthly fee of $20 plus 5 cents per text message sent. Write an equation for this relationship. We have total cost. Our rate of change is 5 cents per text. 0.05 is the coefficient of n, the number of texts. And we have our fixed monthly fee of $20. So we add that to our total costs. B, create a table of values and plot the relationship. Let's say we had 10 text messages. We would replace the n in our equation. 0.05 times 10, that would give us 0.5, and 0.5 plus 20 is 20.5. Let's say we had 20 text messages. We replace the n with 20. 20 times 5 cents would give us 100 cents. That's $1. $1 plus 20 is 21. Let's plot the relationship again. Total cost is on our y-axis. So we'll start at $20 and each line will represent half a dollar. So $21 and 22. And finally, we simply plot the points. So we have our 4 points. We connect those with a straight line, which goes to our y-intercept of 20. There is our linear relationship. Last question. Calculate how many texts you can send if your budget is 50. So they are telling us what the total cost is. In our equation, we will replace our c with 50. And we will solve for n. What should I do on both sides? I will subtract 20. Now, the coefficient of n is 0.05. I must divide by 0.05 on both sides. And dividing by 0.05 would give me a total text count of 600. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.